In question 10, you're asked to calculate average rates of change of those functions. In the first one, there'll be x is between -2 and 6. So what I'll do here, I need to put that function onto my calculator, and we'll see how we go there. So entering the function as shown, what I'm now going to do is to find the values of -2 and then of 6. So end up with -8. And when x is equal to 6, function of 6 in that instance, I can do the sub, but I've got a calculator. So what I might have to do there, I have to actually change my graph just a little bit there because I've actually made it a little bit smaller than I should have. So I'm just going to zoom out, and that might help me to find the figure there. Much better. And that's -24. So the average rate of change, now you can see that's a decrease. Which is going to be -2 in that particular problem. Moving along to B, and this is a linear function, so I won't bother doing anything else. This will actually be the actual rate of change that we're dealing with in the function. I plug the numbers, I've got 38 and then 50. So my average rate of change is equal to 50 take 38 divided by 16 take 12. And that gives me 3 for that particular problem. I don't have units, so I'll just leave it at 3. In the next problem, you're asked to work out the average rate of change for this function, t squared plus 3t minus 1. Just to get a bit of an idea there, I've sketched the graph there. And I'll show you in a moment a very quick way where you can find the actual gradient of the function at a particular point. It might also pay to set up your calculator in that way. So what I might do when t is equal to 1, f of t there, f of 1, sorry, 1 plus 3 take 1 is going to give us 3, or the point 1 comma 3. And t is equal to 3. We've got 3 squared plus 3 times 3 take 1, which is going to be 18 take 1, which is 17, or the value of 3, 17. The average rate of change is going to equal 17 take 3, 3 take 1, 14 on 2, which is going to be 7. So a relatively easy one to work out in that instance. Now, the little trick I'd like to show you on the calculator, I've got my function like so. If you go to settings and you go to graph format, select the derivative /slope. So that means by default, anytime you bring up a function that has a defined derivative at that point, then you'll be able to give that listed. So I'll press that set. And say, for example, I wanted to work out the scenario when x was equal to 2. You can see there the value of the slope when x is equal to 2 is going to be 7. And you can see that as the graph goes down, get a point where it's 0. And I'll get a point, obviously, points, a range of points, sorry. The graph's negative, so sloping down, you can see the value of the derivative change becomes closer and closer to 0, then hits the bottom and comes up becoming positive. A nice little setting on your calculator. So settings, graph format, and select the derivative slope.